Welcome. I'd like to tell you about a new feature that allows you to sum ions into one target ion. So let's take a detailed look at how to sum up multiple ions to arrive at a greater target ion response. And I'll use the MRM transition to sum signals. And if you look at this notation here, I've got several product ions that I'm going to sum up. They come from the same precursor ion, and I'm going to integrate those signals together into a summed signal. So looking at improving signal to noise, signal averaging theory tells us that if the assumption is true that the signal is correlated while the noise is random, ideally that improves as the square root of the number of measurements. So I should get a better signal to noise if I'm able to sum up additional transitions together. So what I'll show you in the demo is setting that up in the method editor, and what I'm going to achieve is for that precursor ion, I'm going to sum up the product ions into one target response. So for the demo, let me start with drugs of abuse. And we've got a target transition and a qualifier transition. So the qualifier goes to 119. So I've added the column MZ additional, and I'm going to create an entry for that qualifier so it becomes the target. And I'll just delete the qualifier to make it simple. So I've got amphetamine with the original transition to 91.4 and one more to 119.4. I'm going to do the same for amphetamine D5. I'm going to take the 124.4 and put that in there and delete the qualifier. So let's follow that in batch at a glance. We're looking at amphetamine. And I can see here the transition says 136 to 91 and 119. And if I look at the internal standard, I'll also see 93 and 124 have been summed to create one target signal and one calibration curve from those target ion amounts. It's worth mentioning that you can add more than one ion in the summing by separating them by a semicolon. You can add, and you'll see here, more than one ion as part of the summed target. Thanks for your attention.